Now dear student, we are going to discuss question number 4.11, and in this question it is given to you, in a chamber a uniform magnetic field of 6.5 Gauss is maintained. Clear? So let's suppose I am taking here, let's suppose I am taking this chamber. Let's suppose I am denoting chamber like this. Clear? So let's suppose this is a chamber and a uniform magnetic field is maintained. So let's suppose I am assuming magnetic field is perpendicular inward of this screen. I am just assuming. Clear? And value of magnetic field is given to you B. This is equal to 6.5 Gauss, or we can say if we convert Gauss into Tesla, then we can say it should be multiplied with 10 to the power minus 4. Clear? And now we can say this value we have in Tesla. Clear? Now it is maintained, an electron is shot into the field with a speed of this one. Clear? So let's suppose I am assuming electron is entering from this side. Just a minute. Yes. So let's suppose I am assuming this is just a pass. Clear? Here we have uniform magnetic field. Clear? Now let's suppose electron is entering from this side. Clear? So this is a side for the electron. Clear? So now let's suppose I am assuming electron is actually entering from this side. Clear everyone? Now we have to find that an electron is shot into the field with the speed of this one. It means value of speed is also given 4.8 into 10 to the power 6 meter per second. This is given to you. Clear? It is normal to the magnetic field. So definitely we are assuming this is an electron and this electron is going perpendicular to magnetic field. Fine. Explain why the path of an electron is a circle. Clear? Now listen carefully. We can say magnetic field is perpendicular to this screen and electron is going in this direction, that is in this plane. Clear? It means now we can say, if we talk about, let's suppose we have any charge and that charge is moving in a magnetic field. Clear? So whenever a charge moves in a magnetic field and magnetic field is perpendicular to that motion of a charge, at that time we can say a centrifugal force will act. Clear? Or you can say we can also find direction of that force by using right hand thumb rule. Clear? So how can we find? You can say, let's suppose this is a right hand. So you can see, let's suppose these fingers are representing direction of a magnetic field. Clear? This thumb is indicating direction of a motion. Definitely I can say this palm represent direction of a force. Clear? So now we can see when this electron is going like this one, definitely we can say a force will act in an upward direction. So it will try to deflect this electron in this direction. Clear? As soon as it reaches to this point, again we can say a centrifugal force will act, centripetal force will act in this direction. Again we can say here we will find deflection of an electron. Clear? So like this, let's suppose this chamber is enough large. At that time we can say this electron move in a circle. Clear everyone? So first question of this particular question is here, explain why the path of an electron is a circle. Clear? Because we can say force acting on that charged particle is perpendicular to magnetic field as well as perpendicular to direction of motion or perpendicular to velocity of a electron. So we can say here directly we can say actually a centripetal force will act, and this centripetal, due to this centripetal force we can say this charged particle move in a circle. Clear everyone? So now we can say this is a region, and now we have to determine what is radius of this circular path. So we can say force acting, this is given by QVB. Clear? And we can say this is sine. Now here we will write angle theta, and theta is the angle between velocity vector and magnetic field. So we can say velocity vector and magnetic field both are perpendicular to each other. So I can say this is sine 90. This is equal to, now whatever the force this is acting here, this force is providing necessary centripetal force. Clear? So I can say this is equal to mv square by r. So I can say this is mv square divided by, I can say radius is r. Clear? So from here we can say, we can write like this, QVB, this should be equal to mv square by r. Clear? So we can say v and v, this one is cancelled out. Clear? So now from here we can write like this, r is equal to mv divided by qb. Clear everyone? R is equal to mv divided by qb. Clear? Now if we talk about mass, so definitely we know mass of an electron, this is given by 9.1 into 10 to the power 31. So 9.1 into 10 to the power minus 31 multiplied with, now velocity vector, velocity is given to you 4.8 into 10 to the power 6. 4.8 into 10 to the power 6 divided by charge of an electron 1.6 into 10 to the power minus 19. Clear? And value of magnetic field, value of magnetic field is given 6.5 Gauss, so we can say 6.5 into 10 to the power minus 4. Clear? Now we have to solve this expression and we can easily calculate value of radius of this circular path. Clear? So now concentrate. Yes. Now from here we can see value of r, this is given by 9.1 multiply 4.8. So 9.1 multiply 4.8 and it is also multiplied with 10 to the power minus 31 and 10 to the power 6. So 10 to the power minus 25 and divided by, clear, 1.6 into 6.5. 1.6 into 6.5 and multiplied with, I can say this is 10 to the power minus 23. Clear? So from here you can say this one is 3 times. Clear? So 3 into 9.1 divided by 6.5 and we can say this is 10 to the power minus 2. Clear? And this is in meter. Clear? Now let's suppose I am assuming this is approximately 6.6. Clear? So 6.6 means we can say this is 2.2. Clear? Now here you can say 9.1 divided by 2.2 or we can say 91 divided by 22. It means this is approximately equal to, we can say 4.2 into 10 to the power minus 2 meter. Clear? So this is the radius of this circular path. Clear everyone? And we can also say the radius is given by 4.2 centimeter. Clear to everyone? Clear? So this is all about this question.